Hi everyone, we're going to graph a rational equation. We're going to call this one g of x because we have so many so far. These are getting harder and harder. And this is the one we're going to do. They get a little harder because you have to factor now. So I'm going to go ahead and factor the numerator as x plus 1 times x squared minus x plus 1. And the denominator will pull out an x. It's going to be x plus 2. And this is your p to the x. This is your q to the x. And I'm going to go ahead and look at the step 6 real quick. The numerator is greater than 1 higher than the degree in the denominator. So since degree in my numerator is 3 and the degree in my denominator is 2, my n equals m plus 1, i.e. 3 equals 2 plus 1. Therefore, we have an oblique asymptote. All right? And we're going to have to determine if it intersects the asymptote later. But we do have an oblique asymptote. You only can have one or the other. You can't have both. It's already in lowest terms. We cannot cross out any factors here after we factored. So we already know that. And we can also find the domain. The domain is all real numbers. You just set q to the x equals 0. And we can see that x cannot be 0. And x cannot be negative 2. That means we have a vertical asymptote at x equals 0 and x equals negative 2. And we don't have a hole because we didn't cross out any factors. It's already in lowest terms. So now let's locate the intercepts. And if we look at the numerator, we're going to set p to the x equals 0. So that's 0 equals x plus 1 times x squared minus x plus 1. This is not factorable, and if you put in the quadratic formula, you get i's. So that means there's no real solutions to that. So we're just going to look at this. So x equals negative 1. So basically, if this is y. So if y is 0, then x is negative 1. We have an x-intercept. And for my y-intercept, I'm just going to write my original 0 cubed plus 1 over 0 squared plus 2 times 0. So we get 1 over 0, which is undefined. That means there is no y-intercept. All right. And now let's check for symmetry. So everywhere there's an x, we're going to plug in negative x. And we're going to get negative x cubed plus 1 over negative x squared plus 2 to the negative x, which equals negative x cubed plus 1 over x squared minus 2x. Since this is neither our original nor our negation of the original, there is no symmetry. We already found the vertical, and now we already know that we have an oblique asymptote because our degree in the numerator was 1 higher than our degree in the denominator. So we're going to divide our x cubed plus 1 by x squared plus 2x. I'm going to put placeholders here. And go ahead and divide. This is going to be x. Remember, asymptotes are a line, so we're going to get x cubed plus 2x squared. You subtract So you're going to get negative 2x squared, and you're going to bring down the 1. So we're going to put up here negative 2. When you multiply, you get negative 2x squared minus 4x. And you're going to subtract. This cancels. This was plus 0x. So you're going to get 4x plus 1. We can't continue, and this would end up being plus 4x plus 1 over x squared plus 2x. This is insignificant when you're taking limits, so basically our oblique or slant asymptote is y equals x minus 2. Now, next thing we need to do is determine if the graph intersects our oblique asymptote. So we set our original equation to our y. So plus 1 over x squared plus 2x. We know this equals our y, but our y happens to be x minus 2. So we're going to put x minus 2 and cross multiply. So we get x cubed plus 1 equals x cubed minus 4x. These go away. So you have 1 equals negative 4x. So x equals negative 1/4. Now our x is negative 1/4. And to get your y, let's go back to the original and plug in negative 1/4. Over, so everywhere there's an x, I put negative, 1/4, and this is going to give us 9/4. So it does cross our y equals x minus 2 at the point negative 1/4 and negative 9/4. Okay, now I'm going to go ahead and test intervals. I'm going to test my intervals from, so this is my intervals. Again, you can put this in the calculator. It helps out a lot. Okay, and basically I'm picking negative 2 and I'm picking 0 because that's my vertical asymptotes. I'm also picking negative 1 because that's my x-intercept, and I want to know what's going on from negative infinity to negative 2 on that interval of the graph, and on my vertical asymptote at x equals 0, what's going on that side. And I also want to know what's going on between my x-intercept, what's going on between the graphs there. So let's just draw lines here and pick points. This is basically if you can't use a calculator. And basically we're going to choose some points, choose some numbers. I'm going to go ahead and choose negative 4, negative 1.5, negative 1/4, and I'll choose 1 here. Okay, and then I'm going to evaluate and find the value of g. So g of negative 4, g of negative 1.5, I'm running out of room, g of negative 1/4, I'll just do it that way, and g of 1. And so what I get is g of negative 4 equals negative 7.875. G of negative 1.5 is approximately 3.2. G of negative 1/4 is negative 1/4 is negative 2 1/4, and G of 1 is 2/3. So I want to know what's going on with the graph, and we can look at location on the graph. So since this is negative, this is going to be below the x-axis. This is positive and this is positive. So this is above the x-axis, both of these. And this one's below. And I'm going to graph this. And I'm going to graph my my asymptotes. X equals negative 2. We also have x equals 0. And I also picked this point here to see what's going on, but on this side of my x-intercept. This was negative 1, 0. I want to know what's going on from these 4 parts. There's actually 4 parts here I want to see. So I picked negative 4, and when I did that, it's negative 2, 3, 4. I got negative 7.8. Oh, let's draw our y equals x minus 2. So our oblique asymptote is right there. This is y equals x minus 2. This helps frame our graph. So down in here I have negative 4, negative 7.875. So this goes like this. There's no symmetry here. I'm also going to look on this side. I picked 1, and 1 went to 2/3. So this one kind of goes like this. Now, on this side, we were above the graph of my x-intercept, and this side we were below, and we didn't have a y-intercept. And you can never cross the vertical. Okay, it did cross my y equals x minus 2 at negative 1/4, comma, negative 9/4. So that's where it's crossing. Okay, that's it. Thank you. Have a nice day. Bye-bye.